In this video, I will walk you through free response question number 1 from the 2018 AP Calculus exam. This problem is an accumulation problem involving an escalator, so we will be working with integrals. This is a calculator active problem, so we will be using our graphing calculator to the fullest extent. People enter a line for an escalator at a rate modeled by the function r given by this, where r at t is measured in people per second and t is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. There are 20 people in line at time t equals 0. Part A. How many people enter the line for the escalator during the time interval from 0 to 300? We have learned that the integral of a rate from A to B gives you the net change in amount from A to B. And that's exactly what they are asking us to find. When they say how many people enter the line between 0 and 300 seconds, they're asking us for the net change in the amount of people between 0 and 300. So to find this, we need to find the integral of the rate of change of people. And that's exactly what r at t is. R at t, measured in peoples per second, is the rate of change of people entering the line. So we just need to calculate the integral of r of t from 0 to 300 to find out how many people entered the line between time 0 and 300 seconds. This will be easy to do because this is a calculator active problem. So let's hit y equals and type r of t in for y1. R of t equals 44 times t divided by 100 to the third power times 1 minus t divided by 300 to the seventh power. So we can just type all of that in like so. I'm using the x variable instead of t. Now we just need to evaluate the definite integral from 0 to 300. So back to the calculator. Let's quit our way out of this by hitting second quit. For the integral, we hit the math button and choose option 9. We are integrating from 0 to 300. And we want to integrate r of t. But remember, we typed r of t into y1. So we just need to get y1 in here. We do that by hitting the vars button, which stands for variables, switch over to the y variables tab, and just choose option number 1 for functions. And there's y1, just hit enter. So here we are integrating y1, which is really r of t. And put your dx on the end. And that's it. So 270 is the answer. Since this is the AP exam, let's write our answer as a sentence. 270 people enter the line during the time interval from 0 to 300. Part B. During the time interval from 0 to 300 seconds, there are always people in line for the escalator. How many people are in line at time t equals 300? The number of people in line at t equals 300 will equal the number of people already in line at t equals 0 plus the number of people who entered the line from 0 to 300 minus the number of people who left the line from 0 to 300. Hopefully this strikes you as common sense. The number of people at any given time should equal the initial number of people plus the number of people who came minus the number of people who left. In the setup, we are told that there are 20 people in line at time t equals 0. So the number of people at t equals 0 is 20. We can go ahead and put that right there. We have learned that the integral of a rate is the change in the amount. So the integral of the rate at which people enter the line will give us the number of people who entered the line. R of t is the rate at which people enter the line. So the integral of r of t from 0 to 300 will give us the number of people who entered the line from 0 to 300. Now we need to subtract the number of people who left. Again, the integral of the rate is the change in the amount. The setup told us that the rate at which people leave the line is a constant rate of 0.7. So if we take the integral of the rate at which people leave from 0 to 300, this will give us the number of people who left from 0 to 300. We could type this whole expression into our graphing calculator right now and get the answer. However, we can simplify this a little bit if we want to. Because both of these integrals have exactly the same limits of integration, they are both from 0 to 300, we can combine them into a single integral like this. So this is the expression that I'm going to type into my calculator, except when I get to the r of t part, remember that we typed r of t into the calculator under y1. So right here, I'm just going to type in y1. So go to a blank screen on your calculator and type in 20 plus. For integral, we do math 9, and we are integrating from 0 to 300. Now it's time for r of t, which we typed into y1. We can access that y1 using the vars button. So hit vars, switch over to yvars, and hit enter for function, and then just hit enter again for y1. So this is really r of t. Now we wanted r of t minus 0.7. And this was dt, but we're stuck with the letter x, which is fine. Just hit enter, and kabam! 80 people. For the AP exam, you should write your final answer as a sentence. There are 80 people in line at time t equals 300 seconds. Make sure you include the units. You will lose a point if you don't put the units. Part C. For t greater than 300, what is the first time t that there are no people in line for the escalator? Here's our thought process. We know that this time t, when there are no people in line, is greater than 300. So let's use 300 as our starting point. So the number of people at time t will equal the number of people at time 300 plus the number of people entering from 300 to t minus the number of people leaving from 300 to time t. But wait a minute, let's look back at our piecewise function for the rate at which people enter the line. For time t greater than 300, 0 people per second enter the line. So no one enters the line after 300 seconds. We can erase this part of the equation. So really we just have this. The number of people at time t will equal the number of people at time 300 minus the number of people leaving from 300 to time t. We are looking for the time t when there are no people in line. So the number of people at time t will be 0. Back in part B, we found that the number of people at time 300 was 80. So we can go ahead and put 80 right here. We just need to subtract the number of people leaving the line from 300 to t. We know that the integral of a rate is the change in the amount. So if we take the integral of the rate at which people leave, the setup tells us that people leave the line at a constant rate of 0.7. So if we take the integral of 0.7 from 300 to t, that should give us the number of people who leave the line from 300 to t. Watch out for this small detail that I want you to be aware of. When you set up an integral defined function like this with a variable for one of the limits of integration, you should not use the same variable at the end. So since I'm using t right here, I'm going to use dx as a placeholder variable. So all we have to do is solve this integral equation for t. To avoid confusion with this negative sign, I would like to move this expression over to the left by adding it to both sides of the equation. So now we have this. We know how to evaluate a definite integral. We take the antiderivative of the integrand and then apply the limits of integration. The antiderivative of a constant is just that constant times the variable, so 0.7x. Now we need to apply the limits of integration from 300 to t, and all of this is equal to 80. So when you apply the limits of integration, you find the value at the upper limit minus the value at the lower limit. So this will be 0.7t, all right, that's the value at the upper limit, minus 0.7 times 300. And all this will equal 80. 0.7 times 300 is 210. So we have 0.7t minus 210 is equal to 80. Adding 210 to both sides, we get 0.7t equals 290. Dividing both sides by 0.7, we get this. You can either truncate and write 414.285 or round and put 414.286. Write your answer as a sentence. There will be no people left in line at 414.286 seconds. Don't forget your units. Part D. For the closed interval from 0 to 300, at what time t is the number of people in line a minimum? To the nearest whole number, find the number of people in line at this time. Justify your answer. In other words, they are asking us to find the absolute minimum on this closed interval, so we're going to need a candidates test. The first step of creating a candidates test is to find the critical values. If we had a function f for the number of people in line, to find the critical values, we would set f prime equal to 0. However, we don't have a function f representing the number of people in line. So instead, we will think of it as setting the rate of change equal to 0. This rate is the rate of change of the number of people in line. For a rate in, rate out problem, the overall rate of change is the rate in minus the rate out. So this is what we will set equal to 0. But in the setup, we are told that the rate in is given by the function r of t. And the rate out is a constant 0.7 people per second. So this is what we will set equal to 0. It will be a little bit easier to find the values of t that satisfy this equation if we add 0.7 to both sides. So we need to find at what times t, r of t, is equal to 0.7. In other words, for what values of t will the rate in equal the rate out? Let's use the graphing calculator to find these values of t. Hit the y equals button. Make sure you have the rate in function typed in as y1 and the constant rate out of 0.7 typed in as y2. We want to find where the rate in equals the rate out, and we're going to use the graph to do that. However, before you hit that graph button, let's adjust the window. So hit the window button. Right now we have a default window of -10 to +10 for xmin and xmax. What kind of adjustments do we need to make? Let's start with the given interval. We are looking at only values of t between 0 and 300. That's your xmin and your xmax. So let's make that adjustment. The xmin must be 0 and the xmax will be 300. Now the ymin and the ymax takes a little bit more thought. The main thing I'm looking at is the fact that the constant rate out is -0.7. that's a pretty small number. So in general, we are talking about small numbers probably for the rate in and the rate out. So we might make the y max be something small like 1, 2, 3, or 4. We can always adjust this later, but I think I'll go with, let's say, 3. For the y min, again, -10 is very big, and we know these rates are not going to be negative. So I think I'll just make it -1. I always like to see a little bit below the x-axis so I can clearly see what's going on. Let's go ahead and hit graph right now and see what we've got so far. Ooh, that is a very nice looking graph. So we are looking for these 2 points of intersection. So hit second trace, and option 5 is for intersection. Move your pointer close to the first point of intersection and hit enter 3 times. Enter, enter, enter. So this is our first critical value, 33.013. I would like to store this into a letter for future use. So hit second quit, hit the X button, hit the store button, and I'm going to store this value into the letter A. So alpha A, enter. When I need to use this number later, I can now just type A instead of typing all of these decimals. To be clear, if you don't use this shortcut, if you need this number again later, you're not allowed to just type in 33.013. You have to use all the decimals that you see here. Let's go back to that graph and find the second point of intersection. So second trace, intersect. Now move the pointer close to the second point of intersection and hit enter 3 times. Enter, enter, enter. This is the second critical number. Again, second quit, let's store that number into a letter. So hit X and the store button, and I will store this value into letter B. So alpha B, enter. So we have our 2 critical values. For the candidates test, we need to find the number of people in line at the endpoint times 0 and 300, and the number of people in line at the critical value times that we just found. In the setup of the problem, we are told that there are 20 people in line at time t equals 0. So the first value is given. The number of people in line at 33.013 seconds will be the initial number of people plus the number of people who entered the line by this time minus the number of people who have left the line by this time. The initial number of people in line is 20. We know that the integral of a rate is an amount. So the number of people who enter the line will be the integral of the rate at which people enter the line. So the integral of r of t. This expression represents the number of people who entered the line from 0 seconds to 33.013 seconds. Similarly, the number of people who left the line will be the integral of the rate out, so the integral of 0.7. This expression represents the number of people who left the line from 0 seconds to 33.013 seconds. Because the limits of integration are identical, we can write this as a single integral. We can type this expression into our calculator. Just remember that 33.013 is A, and r of t is y1. So let's type 20 plus. For integral, we do math 9. We want to integrate from 0 to a, so alpha a. And then for the rate in, that's y1. We will type vars, yvars, enter, and just hit enter for y1. We could do minus y2, but it's even simpler just to type 0.7. And that's it. 3.803. We were asked to round to the nearest whole person, so we will just put 4. Similarly, the number of people in line at 166.575 seconds will be given by this expression. Just remember that 166.575 is the value b. So back to the calculator, I could type in this expression again, replacing a with b, or small shortcut, if I come up to this expression and hit enter, all I have to do is go over to where a is and type b instead. So alpha b and enter. 158.070. That rounds to 158 people. Finally, the number of people in line at 300 seconds will be given by this expression, so we just need to change the b to a 300. Again, to save time, I will just go back to the expression I typed in, and I will simply navigate over to the b and replace it with 300. Kabam! 80 people. Remember, we are looking for the minimum number of people in line and the time when that occurs. And we find it right here. The minimum number of people in line occurs at t equals 33.013 seconds when there are 4 people in line. See Candidates Test.